Good morning. I hope that we are all fine and that we are doing well. The rest will join us even as we continue. So today we want to look at interaction diagrams. And so by looking at interaction diagrams, we are going to look at two particular kind of diagrams: sequence diagrams and collaboration diagrams. So interaction diagrams. Let me share the screen so that we can begin our discussion today. Okay. So interaction diagrams basically, they show how different objects in a system relate to one another. These objects can be users, human users, or abstract objects that are inside the system. Abstract objects like modules in a system, subsystems in a big system that interact with one another. So the objects can be human users, physical objects, or abstract objects. And basically, interaction diagrams show how these particular objects, whether physical objects or abstract objects, pass messages to each other. Okay, so interaction diagrams basically show message passing in the diagram. It depicts how messages are passed from different objects to different objects. They might be physical objects or abstract objects. So there are two kinds of interaction diagrams you're going to learn today: sequence diagrams and collaboration diagrams. Okay. Now let's begin with sequence diagrams. Sequence diagrams are interaction diagrams that illustrate the ordering of messages according to time. Ordering of messages according to time. In other words, when you draw a sequence diagram, the lines, the arrows that are shown, that are drawn to show the messages that are being passed from one object to another, are drawn according to time, according to what time that message is passed, because messages are passed during different times from object to object. For instance, when this activity happens, there will be data that will be sent to another object. And then that data cannot be sent when that particular activity does not happen. When another activity happens, then there is another data set that is passed from one object to another. So it illustrates the ordering of messages according to time. Now, how are sequence diagrams drawn? Sequence diagrams are drawn in form of two-dimensional charts where the objects that are interacting with one another are drawn in the x-axis, horizontal axis, and they are drawn in form of a rectangle, and the messages being passed are shown. The messages that these objects are sent or are being passed between object to object are shown in the y-axis, and they are shown using arrows. Let me show you how this works. So how do we draw these things? So basically, you first draw them. You draw them this way. You draw, these are the objects. The objects, depending on the number of objects there are. So I'm going to copy and paste this. So let's say your scenario, your system scenario has 4 objects. So you're going to group those objects there. And of course, every object has to be named, okay? So you can call it, you call it whatever, right? So object A, so you group them in the y-axis. The objects that interact with one another, you group them in the x-axis. The x-axis is the horizontal axis. And of course, you name each object. And then these objects pass messages to each other, okay? So how do you show how message passing is done? You show using in the y-axis, but there is something very, very important to show. This is what you do. So you come here, and then you're going to draw a grid, right? I'm just demonstrating how this one normally happens. I'm going to draw a grid. Just a minute. All right. So I'm going to draw a grid. This grid basically is just to show that there are messages that are being passed between object and object. So for instance, I'm going to copy and paste this, but this will vary based on the kind of the instance, the scenario that we are given, okay? So this will vary. So you have grids in the y-axis. These grids are basically to show how these objects interact and pass messages one to another. So a grid can be longer than another, all right? So for instance, that grid can be short. So if object A and object B is sending a message and object A is communicating to object B, then you draw what? An arrow. Right, arrows are used to show the relationship that there is actually a message being passed, and then on top of that arrow you write the kind of message being passed, and write it on top or below it, right? So you write the message that is being passed, and if message object B is sending a message to object A, you also draw what? You also draw an arrow to show that. And then of course you write the kind of message that is being passed. All right. If object, look at what I'm going to do here. If object D is sending a message to object C, to object B, if object D is sending a message to object B, if D is sending a message to B, then you draw that. Now, one thing that you have to note, these grids, these ones, these grids should not crisscross, these arrows should not cross these grids, okay? They should either pass above or below them, okay? And if object B is sending a message to object C, you basically just show that way. And then of course you write the message, related to that particular arrow, the data that is being passed. And yeah, so you object, you see how these messages are. So basically I'm just trying to show you how sequence diagrams are drawn, because we're going to draw a scenario, and therefore that scenario is going to help you to understand even better, okay? Now so you show that way. This is how you show it, okay? So if there are messages, you just show them in that manner, okay? So if one is sending a message to another, you show. If another is sending a message to another, you show. Basically, that's how sequence diagrams normally are drawn, okay? And of course, we are going to see how others are drawn. You know how a sequence diagram in a case scenario is drawn. So basically, these are just to show that these are objects that are sending messages to each other, okay? Now I want us to have a case scenario. Now this case scenario is going to say the following. We can say we had a scenario for bank. I think we can use this scenario for bank here, okay? So we are going to copy this bank scenario and then draw a sequence diagram for it, okay? So yes, Paul, I'm going to show you how that is going to work. If it is from A to E, you're going to expand this. You're going to expand this grid, okay? So that now you will have an arrow, and also expand this one, so that now you'll have an arrow that starts from there to there, okay? So never should they ever cross, okay? They should never ever cross, all right? They should never ever cross. Those grids should never ever cross. So you normally expand those grids. You expand those grids so that they don't cross. Thank you for that question. All right, so let's draw this a sequence diagram for this. So we are going to say represent this system using a sequence diagram. Now, what is happening here in the bank scenario given above? A customer. So the first thing is to identify the objects. Okay. The first thing is to identify the objects. So objects are people or entities that are interacting with the system, or that are interacting with one another. So there is a customer, right? Can perform the following activities: register account and borrowing loan. So there is account registration. The account registration is a what? Is a module, okay, in the system. Yeah, it's a module in the system. It's an object. Then there is also loans. Loans is a module. Loans is a module. When he successfully registers the account, he receives a message. In borrowing a loan, he or she enters the loan details and the system processes the loan and sends the details to the branch credit officer. So there is a credit officer. Just a minute, I'm admitting people here. Credit officer, and who else? The branch manager. Now these are very, very simple. Very simple. I want to save on space here, but I can have space to draw. So these are the objects: customer, account registration, loans, credit officer and branch manager. Customer is a physical object. Credit officer, branch manager is a physical object. But account registration and loans, these are abstract objects, meaning they are entities within the system that interact with one another. Okay. So now we are going to draw a sequence diagram that represents this. So I'm just going to copy and paste these. I'm going to paste that. So so I'm going to call this customer, right? And then of course I'm going to copy and paste. Now, how do we normally arrange these objects? You'll realize that if you arrange these, all right. Sorry, I was away. My connection was poor. So let me share back this screen. Okay. All right. So let me continue. So as I was saying, the way to know how to arrange these objects is based on how the frequency of the objects and how the objects, the frequency of the messages and how the messages are being passed, because there are objects that are frequently sending messages to each other. Therefore, those objects are going to be close to one another. All right. Why? Because you don't want to have very, very long grids as in a bid to not crisscross them. You want to have just grids that are normal. You don't want to have a grid that starts from the top of the page to the bottom. It doesn't, especially because these systems are not going to be given to you, with a lot of detail. So you want grids that are just short grids. All right. So basically, you have to keep objects together. The objects that are sending messages to each other so much, keep them together. All right. So that they can actually be together, so that they can actually send messages. Okay. So I'm just going to create the objects, and then I'm going to determine which ones. So normally you determine that as you draw. All right. You determine that as you draw. So customer, then there is account registration. I'm going to actually expand this. All right. After loan verified, the customer receives a message from the banks. Customer receives a message from the bank's credit officer, money manager, banks manager. Yeah. Okay, so I've just expanded so that it can make more meaning, can make more sense. So there is customer, then there is accounts registration. So this is a module, an object, accounts registration. Then there is loans. And there is what else? Credit officer. officer. And then there is branch manager. So if after loan is verified, the customer receives a message from the bank's branch manager or not. After loan is verified or not. All right. After loan is verified and disbursed, the customer receives is not disbursed, accepted or disbursed. If it is not accepted or disbursed, customer receives a message from the credit officer. Okay. No, the customer also receives a message from the bank manager. Don't worry, you're going to see why I'm making those changes in the diagram anyway. So we have credit officer, bank manager. Okay, so then let us draw the grids. Let us draw the grids. Grids. Okay. So what does the customer is the central object. So now I'm showing you how to determine which object should be near which one, so that we don't have to draw very long grids. Okay, but you see the customer is the one which is dealing with the in the system, is the one who is interacting with most of these. Do you actually realize that the customer is the one interacting with most of these other objects? So if the customer is the one interacting with most of these other objects, we would want to put the customer object as the central, as at least central, so that the messages can go left and right. So we don't want to have messages going right. So if all the messages from customer are going right and all the messages to customer are coming to the customer, and the customer is at the further end, meaning that his grid is going to be very long, so that we don't intersect messages with the grids of the other object. Okay, so that's why nimeiweka hapa katikati, so that we don't have to, it can communicate with others without us having to increase the size of the grids. And you see our page icon. So you normally do that. The object that is sending more messages or receiving more messages, you keep them close to the others and central. Okay. All right. So so there is customer and there's loans. So the first thing the customer does, what? He registers. Okay. In fact, just see what I'm going to do. The reason I'm changing this is because in my head, I'm looking at the objects that I'm looking at a scenario where the objects are not going, the messages are not going to crisscross. So when you'll be going to be drawing your sequence diagram, you're also going to factor in that particular factor. So the customer first does what? Okay, of course, registers for an account. So I'm going to just minimize this grid. Okay, just that. And then I'm going to have a grid for the customer. So the customer and he successfully registers an account, he receives a message. So look at what's going to happen here. So I'm going to have an arrow to show registering of account. So he registers account by giving that particular module his details, right? For you to register an account, you have to give customer details. Isn't that so? So we give customer details. The customer gives his details. Then when he successfully registers, he receives a what? He receives a message. So can you see that object sends to that object a message? So you can actually see success registration. Okay. I think that looks fine. All right. Okay. And then, so can you see now how the purpose of the grids? The purpose of the grids is just to show the messages that are being passed from one object to another. Then the customer also does what? He borrows a what? A loan. Okay. So I'm going to draw. So what messages, what details does he? So in borrowing a loan, he or she enters the loan details. Okay. So we are going now to have a message. It's the customer that is borrowing a loan. So he's giving this module a message. Data, right? Message is data. Okay. So just going to have that way. And then I'm going to write here loan. All right. See that? And then after he sends the loan detail, when he processes the loan and sends the details to the branch credit officer. Okay, you can see we have 10 minutes, less than 10 minutes remaining. So let's rush a little bit. So this particular object here, it sends a what? A message to who? To the credit officer. So this particular module, this object here, it sends a message to the who? To the credit officer. So it sends a message about the loan. Okay, about the loan. I'm trying to hurry so that we can finish that. So it sends a message to the credit officer. Just trying to have it like a straight line, that's all. Okay, and it also sends a message to what? To who? To the branch manager, right? It also sends a message to the branch manager, doesn't it say so? To the credit officer and the branch manager. Okay, so it also sends a message to the branch manager that way. So of course we can shorten that. We don't need it to be too long if there is no other message being passed. Okay, so it will send a message about the loan details to the credit officer and a message about the loan details to the bank manager, branch manager. Then what will happen? Who can verify the loan? After loan is verified and disbursed, the customer receives a message from the bank's branch manager. So I'm going to look at this, look at what will happen. So I've shortened this grid because of something that will happen here. Okay, so e-grid near credit officer, please don't forget that this grid is just for the credit officer, it's just that it has been shortened. Okay, so it says here, if after loan is verified and disbursed, the customer receives a what? A message from the bank's branch manager. So look at what will happen here. So success message. So I'm going to have an arrow to show a success message. we go. So it says after loan is verified and disbursed, customer receives a message. Okay, so we can actually say loan verified and disbursed. Okay, then if it is not accepted or disbursed, the customer also receives a message from the bank manager. So what is happening here? There is what we call when there's a message when there is a true or false statement. A true or false statement. I can see we have less than 6 minutes. When there's a true or false statement, we normally represent that true or false statement as a constraint. All right, and I think we saw that in DFD diagrams. And let's see how constraints work. So when it has been accepted, then it works like that. If it has not been accepted, then you write it like a what? Like a constraint. Okay, like a constraint. And this is how you write it, like a constraint. Loan not verified, not disbursed. That way. Loan not verified, sorry. Loan not verified, loan not disbursed. And then you put it this way. You put it with the parenthesis to show that that is a false. It is a false, when a message that should be sent if the scenario returns false. Okay. So that is it. That is how you represent that system. That is how you represent that system. Okay. All right. Any question? Any question? Can you see how we have grouped these objects so that we don't have crisscrossing of messages? We have grouped them in a manner in which we will not have to really expand the grids. Okay, to really expand the grids. And what I've done so that we don't have to have very, very long grids is that the objects that are frequently sending or receiving messages are put in the center. Okay, like in our case, customer object is put in the center, so that imagine if we had put customer at the right or at the left. If you had put it at the right here, we're going to have a very, very long grid, because there are a lot of messages coming from it, from the other objects, and a lot of messages going from it to the other objects. So that the grid is going to be too long, because we are in trying not to cross the other grids. Okay, so the you know the ones that are in the center are the ones that are normally sending and receiving a lot of messages. Okay, in order to optimize on the length of the grids. Any question before I give you a question? You can unmute yourself and ask a question. You can type in the chat area, whichever you feel fit. Okay, there's no question, then I'm going to ask you a question, right? So here goes the question. We have now 2 minutes remaining. So let me just give you this question here, and then you can draw it. And I will allow someone to show us what they have. So this is the question. So that's the question. So read that question, and as I create another session, our session is ending in the next 1 minute and some seconds. So as I create another session, read that question and begin it.